Okay, so introduction to structural design. So I believe, like I said last week, you have learned about different kind of construction system. Okay, in building construction, building construction 1, building construction 2. You learn about timber construction, concrete, steel. Okay, so but basically what you learned before was just to put things together. Okay, how you want to construct your building. Okay, how to put different components of the construction system together to build a building, right? To construct a building. Okay, but in this class, basically, you are going to learn slightly different than that. Okay, so by the end of this lecture, basically, what you should be able to learn or you should be able to do is to know the basic issues that affect the design of building structures. Okay, so I'm not sure, but I think probably right until semester 4, right until now, when you design a building, you don't really put so much consideration on structure or design, right? So you just play around with this, not play around lah. I mean, you just concentrate more on the spaces, okay? Theories behind the whatever spaces that you try to create, and maybe narrative of your design, okay? So why do you design like this? You need to create some kind of story, right? And normally construction structure would be the last thing that you consider. Okay, so maybe when it comes to week, you normally you submit in week 14, right? You submit your project in week 14. So maybe in week 12 or week 11, then only you want to consider what do you want to put, how you want to put up the building. Okay, the construction system of that building. Okay, but by right in practice, when you start designing something, when you're given a task to design something, right from the beginning, you have to consider construction and also structure of the system. So how do you want to construct the building? Okay, so you have to consider what kind of material you want to use. Okay, you need to consider what type of load that the building would actually cater for. Okay, so because of that, in this topic, basically, I'm going to show you the issues or the things that you need to consider when designing structural design for building. Okay, so basically, it's not just about aesthetic, right? So you learn about aesthetic in design studio, right? But I would say if too much aesthetic is not it's not really good if you concentrate too much on aesthetic without considering the structure construction system of the building. Okay, so by right it should be balanced. Okay, so afterwards I'm going to show you that, okay, what you need to consider when designing the structural system. And then the second one is, I would say today's topic, there's some kind of relation to whatever you have learned in building construction 2. Okay, not to say overlapping lah, because in building construction 2, you still remember what you have learned in Beacon 2? Yeah? No, cannot remember. Huh? Bus shelter. So that's the only thing you remember. Okay. So I remember you have to construct the bus shelter, right? 1 to 5, is it? The scale 1 to 5 or 1 to, not 1 to 1, right? 1 to 5. Okay, so the bus shelter. I think in Beacon 2 you learn about skeletal surface, right? Solid construction, that kind of things. Okay. But what would be related in this structure class, which relates to Beacon 2, is I believe you learn about forces. Okay, so in one part of Beacon 2 you learn about forces. Okay, so we cannot talk about building structure if you don't talk about forces. Okay, so there would be some kind of revision, I would say, on Beacon 2 topic related to forces. And then finally, understand how load is transferred within a building. Okay, so in order for you to understand how the structural system of building works, so you need to know how the loads are transferred inside the building. Okay, so from, let's say, from the roof where it goes, okay, from the floor, so where it goes, which part of the structure that carries the load, and so on. Okay, why learn building structures? Okay, first, so the architect can solve structural problems. I'm talking about simple structural problems. Okay, because in practice, basically, depending on which firm that you are working for, or maybe you want to have your own firm. Okay, you want to establish your own firm. Some firms, they only deal with small projects, only bungalows. Okay, they don't want to take big projects, right? But so normally for bungalows, for small projects, the structural system more or less the same. It's quite simple. You have something like this. You have beams, okay, the ground beam, and then you have basic roof system and so on. Okay, so as an architect, you need to be able um, to size. I mean to suggest to propose a specific size for the beams and so on, because it would appear in your design actually. Okay, so when you produce your elevation, you produce your section, right? So you cut the building, and then you need to show the beam and all that, right? So you should be able to put in the appropriate size for the beam. Okay, so that what you mean by to be able to solve structural problems, eh? And then to determine the distribution of stresses and to compute beam column sizes, okay, for a simple class of building, right? Distribution of stresses is quite important. For example, like um, I believe you guys like to design cantilevered component, right? Cantilevered roof, cantilevered beam, slabs, and all that, right? So you need to understand how the stresses in that kind of structure transferred into the whole building system. Okay, is there any aircon? No aircon, is it? It's a bit warm. Huh? Oh, no wonder. Oh, okay. So did anyone turn off the switch actually? No. Okay. Then secondly, structural elements can be sized with the use of table charts and so on. Okay. So basically, you don't really in practice you don't really have to do calculations to determine the size of beam, because that would be done by engineers, especially when it comes to big projects. Okay, we have a lot of beams, different beams, and then you have to use different size for different part of the building. Okay, but as the rule of thumb, okay, for basic sizing, you can refer to tables and charts to determine the size of the structural elements. And then secondly, so that architect can talk more intelligently to their engineering consultant, okay, so that you don't appear like if women maybe like dumb blonde or something, right? So you go on site and then you know nothing about over construction, and then the engineer say this, contractor say this, and then you cannot really get what they're talking about, okay, especially when it comes to structure, right? So when they mention something, some vocabularies related to structure, for example, like shear, deflection, okay, so maybe they would say, oh, there's a deflection on the beam on the first floor. Okay, so you know what deflection means. Okay, but if you look at this image here, I don't know whether this architect first. There's no architect, especially in Malaysia, where's like wearing like that, right? Going to the site. Okay, so that's that's one thing, and then you can see the face lah. I'm not sure whether he understands what the contractor or the engineer is talking about. Okay, so trying to maintain his face, right, as if he knows what the contractor talks about. Okay, and then the third, which is the most important factor, most important thing why you learn building structure is so that with a good understanding of building structures, you would be able to design a rational and beautiful buildings. Okay, because you understand, right? You understand if you put the column like this, whether the building would collapse or not. Okay, so you can play around with when you understand how the structural component works, you can design, you can play around with the design. So for example, like column, okay, maybe you want to put the column at a certain angle or something, whether you can you can do that or not. Okay, things like that. And if you look at this image, basically, I believe a lot of you like this kind of structure. You have a very long cantilever. Okay, so you wish you can do this in all your design. Okay, without any column, right? So not obstructing the ground level. Okay, but first you need to understand how you can construct this kind of structure. Okay, so if you look at this image here, you can see that it is not using the normal construction system that you have learned before in Beacon 1, Beacon 2. Okay, because I believe in Beacon 1, Beacon 2, what you learn is basically normal column beams, right? And trusses, I'm not sure. But basically, this system is using truss system, just like the system that we use in bridges Okay, so using that kind of system only, then you can construct, you can cantilever like this. Okay, so only with basic qualitative understanding of structural theory will a structure be born healthy, vital, and possibly beautiful. Once a structural system has become common, it can be successfully integrated into an architectural design without much consideration of structural theory or behavior. Okay, so at first maybe you would find it a bit difficult for you to, um, I mean, you just learn about the structural theory, behavior, and all that, and at the same time you try to implement that in your design. Maybe at first it's a bit difficult because you need to estimate how far can actually the beam span, okay, the trusses span, okay. So how tall or how the column can go, so things like that. But once you are familiar, you have done this many times, then it won't be a concern anymore. Okay, so hopefully starting this semester in your final design, semester 4 final project, semester 5 and semester 6, um, you would put consideration into structural system of your design, okay, right from day one when you start your design. Okay, so the basic thing, the usual problem in design normally would be um, columns lah. Okay, so when you first design your spaces, right, of course you want to show your lecturers that the spaces, there's no column inside the space and all that. But then towards the end, when you want to start producing the final scheme, okay, the final presentation board, then only your lecturer asks you to consider construction. By that time, I think it's too late, because if you try to include, if you try to put in the structural components later in your design stage, then it would disturb your original design. Okay, so for example, at first you already have nice spaces in your plan without any column, and then suddenly towards the end when you want to produce the final scheme, then only you want to put columns. Okay, so then you have to shift your wall here and there, and at first maybe your space you don't have any column, and suddenly, because there's a certain way you should put your column, okay, you cannot simply put your column anywhere you like, and because of that it would disturb your spaces. Okay, so that's why I'm not sure whether your design tutor has mentioned this to you earlier, but by right from the beginning, you should design using grid lines, right? So not necessarily it has to be vertical, horizontal. It can still be, for example, like if you have different component in your design, maybe like one side of your building, it can be vertical, horizontal, and then different side it can be a bit slanting, depending on the site as well. Okay, so not necessarily grid, when we say grid line, it has to be vertical, horizontal. Okay, so it can also be something like diagonal. Okay, but you have to include it in your design, right from the beginning. Okay, the basic concerns in structural design, um, as uh, as what we have done last week, during the activity that we have done last week, regarding the chair design, right? So basically all physical objects, as I mentioned last week, all physical objects have structures. Okay, it's just that of course the structure would be different between objects. For example, like if you look at a ball, okay, there is some kind of structure for the ball, but of course it's not using concrete. Okay, of course it's not concrete structure, right? It uses rubber, right? But then and then you have to uh, put air inside the ball so that it can sustain the shape. Okay, and then why we use rubber? Because maybe because you want to bounce the ball. Okay, so only rubber is the most suitable materials. Okay, so for whatever object that you design, that you can see, okay, in this world, there is a reason why the structure is like that, right? So for example, like last week we have done the activity regarding the chair. So there is a reason why the structure of the chair was designed like that. Okay, according to the purpose, basically. Okay, the design of structures is part of the general design problems. Okay, I think in your design modules, when you got the project brief, assignment brief, okay, basically that's the problem that you are going to solve, that you need to solve for that project, right? So in the brief, basically it mentioned how many spaces that you need to produce. Okay, so where's the site? Okay, so basically those are design problems that you need to analyze, you need to consider. Okay, so you went to the site, you study about the site. Okay, site is one of the design problem. Okay, so you do site analysis to find out to provide solution for based on the analysis that you have produced. Okay, but seldomly you consider structure as the one of the design problem. Okay, so I would like to highlight here that design of structure is part of the general design problems. Okay? So that's why you should consider it right from the beginning of your design. Okay, for example, if you can look at these three images here. For example, this building here. Anyone knows what building is this? What do you call it? Apple, apa? Apple. I know Apple lah, but then Apple. Is it a bus stop? No, Apple Store in San Francisco. Okay, all right. What do you think the problem that it tries to solve, the structure tries to solve in this design? Okay, so basically, I believe the designer, he wants to have something. He wants to make the Apple logo look floating. Okay, right in the middle. So the only way he can do that without any obstruction is by using glass. Okay, so that's why the designer basically uses glass. Okay, for the whole structure. I'm not sure whether to call this a building or not, but it's a structure. So maybe the store is below, underground. Okay, so something like the Louvre in Paris, right? So you can see the structure on top, right? But there is a reason why the architect basically used this kind of structural system for that building. Okay, to show what's inside. Okay, and then because of that, because the architect, the designer wants to have that kind of effect, so all the structural components need to be constructed using glass. So you can see that I would say some kind of column here using glass, the beam also using glass. Okay, and also the envelope of the building, the roof, everything is using glass. Okay, but in order for you to do that, you need to consider several things, which I'm going to explain afterwards. And then the second one here, basically, so what do you call this kind of structure? This kind of construction? You learn last semester, right? Bicon 2? Huh? Apa? Pneumatic. Okay. Yeah. So it's pneumatic structure. Okay. So there's certain reason why the architect use pneumatic structure, and if you want to use pneumatic structure for that particular reason, so you need to know how to construct. Okay, how to put on the structures to hold that kind of system. Okay, and then last one, it looks like Libeskind, right? Is it Daniel Libeskind design, or do you know whose design is this? Because I don't know, that's why I asked. Okay, anyone knows? No, don't know. Okay, it's just a random image I got from the internet. Okay, so I believe some of you, if not all, some of you like this kind of design. Okay, it's just like Zaha Hadid wannabe. Okay, Daniel Libeskind wannabe. So you try to do that, to do this kind of construction system, the structural system in your design, right? But you cannot simply do that without any knowledge of how the structural system works. Okay, so how do you want to carry the roof, right? Then how the load from the roof is transferred throughout the building and so on. Okay, you cannot simply put a slanted column. If there is a slanted column, I'm not sure. Okay, you cannot simply put like that in that kind of angle, right? Without some kind of knowledge of doing that. Okay, so whatever you do, you want to do in your design, so you should know how to construct. Okay, you should know how the structural system works before you can use it in your design. Okay, I think I've mentioned to you last week, right? Last time when I studied architecture, my lecturer told me that, okay, if you don't know how to construct the building, okay, then don't do it. Okay, don't do the kind of construction system, the structure system that you want to do. Okay, if you don't know how the system works. Right. So now um, I'm going to tell you the things which you need to consider in your assignment one. Okay. So basically, what you need to do, if you have seen the brief, the assignment brief, right? Basically, what you need to do is you need to comment on the existing design. So once you have chosen the one scheme from your group among the group member, let's say you have 5 or 6 members in the group, you need to select one design scheme of your semester 3 design project, final design project. Choose the one which has a huge room for improvement in terms of structural system. Okay, and then as I mentioned in the brief, I think if you got A for that scheme, not necessarily your structural system is good, and vice versa. Okay, not necessarily if you got C for your design semester 3, then your structural system is not good. Okay, so sometimes because you concern too much on the construction system, on the buildability of the building, it might cause your design to be a bit boring, I would say. Okay, so that's why you got C maybe for your design. But sometimes maybe the lecturer they want to see more on the exploration of ideas, especially up until semester 3. So they want to see more on exploration of ideas and design. So maybe you got A for that scheme due to your design exploration. But then when you look closely into the structural system, they don't work actually. Okay, so you need to select the building wisely. Okay, the one that you want to use for the assignment. Okay, okay. The first thing that we concern when we design the structural system is about safety. Okay, this is the major concern. Okay, the main concern when we design a structural system. Okay, for a building. Okay, two critical considerations. Right. First is, if you look at this image, it's about fire resistance. Okay, fire resistant and sustaining loads. Okay, I think these two concerns relates very well with this image. Okay, I believe you know this incident, right? The 9/11 incident. Okay, so first we talk about fire resistant, right? So when you design a structural system for a building, it has to be fire resistant. Okay, you cannot afford to use a construction system, a structural system which is not fire resistant. Okay, so as once it caught fire, then it would burn everything. Okay, something like that. All right, so it has to be fire resistant. But looking at this incident here, basically, um, because the building was constructed using concrete and steel, right? So basically, by right, I mean the fire resistance is quite okay. And then because the attack was on the upper level of the building, okay. But how come the whole building collapsed? Okay, so if you know about this incident, basically, some people actually they came up with some conspiracy theory behind this lah. So they say it's not a terrorist attack, right? But there's a, I mean, somebody has actually put bombs below there, and then they once the attack happened, so they basically they just blew up the whole building. So that's how the building collapsed. Okay, I think you can get some information. I mean, I'm not sure whether you can trust the information or not, right? But yeah, so some people say that it's a conspiracy theory. So that's how I relate to this sustaining loads. Okay, so by right, the structure should be able to sustain load as well. Okay, but actually it's also logical because once a structural component, right, caught fire, basically it would reduce the strength of the material. Okay, so that's how it collapsed. But then what we don't know, or what puzzles a lot of people basically, is how come the whole building collapsed, right? When the only the fire happens only on the upper levels. Okay, so that's the thing. Okay, so these two these two considerations falls under safety, right? So because you need to make sure that when you design your structural system for the building, it has to be fire resistant, right? And also it should be able to sustain loads, right? Of course, loads is quite um, how to say, is quite it opens to interpretation lah, because it depends on how much load it needs to carry. Okay, so first let's look at the fire resistance. So major elements of fire resistance: combustibility of the structure. Right, so you need to make sure that the structural system that you use, especially related to material that you use for the structure system, is combustible. Okay, so if structural materials are combustible, they will are not combustible. Sorry, if structural materials are combustible, then it would contribute fuel to the fire. Right. So you are taking services this semester, also, right? Okay, so basically, but I don't think you have learned about fire yet, right? So when you learn about fire protection system in building services this semester, so you would learn about this thing again, right? So what contributes to fire? Okay, so you need you need oxygen, you need fuel, right? Another one is you need to you need have what, oxygen, something like that. Okay, so you need to make sure that the materials that you use for the construction is non-combustible, right? So that would be the first one of the things that you need to look in the assignment, right? So you need to look at the fire resistance of the design, whether when you look at the design, whether it's fire resistance or not, right? And then you need to provide some discussion. You need to discuss about the materials and so on. And then secondly, loss of strength at high temperature. This is what I mentioned earlier. Okay, so you need to use a material which um, doesn't lose its strength, okay, at high temperature, or maybe very slow. Okay, so that's why in buildings we use fire door. We don't use you don't simply use a normal door. Okay, we need to use a fire door, especially at the exit points, right? So because if you use a normal door, right, it would easily lose its strength. Yeah, and then let's say the fire happens next door, and then if you use a normal door, and then easily the fire would get in the other space. Okay, and then the containment of fire. Okay, need to make sure that the system, the structure system they use, the construct material that you use for the structure, contain the fire just inside the space, right? So it doesn't travel to the other spaces in the building. Okay, so if you look at the image here, right, I'm not sure whether it's, I don't think it's Malaysia, right? Because we don't really have this kind of squatters in especially in KL, right? So I think if you read in the news, there are many times squatter areas caught in fire. Okay, because of what? Because of the material that they use for the houses. Okay, they simply use sometimes just use plywood for the wall, right? And then sometimes the roof also they use plywood. Okay, because they don't have the budget, so they just use whatever to build the house, to construct the house. And then the houses within the squatters, they are very nearby, right? They are sometimes they attach to each other, right? Even though the house that we stay, I think most of us we stay in the terrace houses. So even though they are attached, all the houses are attached, but if you are aware that between the two houses there would be a what we call a party wall. Okay, so I think you learn in construction. No, not yet. So maybe in structure, in services. Okay, so because of that party wall, it blocks, it contains the fire from spreading from one house to another house. Okay, so you need to use appropriate structural system for that as well. You cannot simply use any material for that party wall. Okay, so coming back to this image here, right? Because of all these three things, right? All these three points, it causes the fire to spread. Okay, maybe initially it start from this point. Okay, but over a few hours or a few minutes, it spreads across the squatter area. Okay, because of the material that they use, because of the loss of strength at high temperature, loss for the materials, and then because of there's no containment of fire, right? So the material that they use for the house, for the squatters, cannot contain the fire from spreading from that house to another house. Okay, I think if you know, not sure whether it is covered in history of Malaysia or not, or maybe history in history of Kuala Lumpur. But I think in a lot of major city centers, major towns or major cities in the world, not only Malaysia but in the world, there would be what they call as the big fire event. Okay, so in KL also, one of the cities, KL, okay, the big fire of Kuala Lumpur last time. I'm not sure, I can't remember which year was that. I think probably in 18 something, right? 1881 basically. Right. So before the big fire, basically all the construction, all the materials, the construction system they use for, um, especially the shop houses in KL are normally timber, right? So a lot of the building are using timber, right? So once one of the unit caught fire, it spreads across the entire city. Okay, so after that, basically the authority create or come up with a law, okay, to ban the use of timber, especially in the construction of shop houses. Okay? So it has to be replaced with masonry construction. So another concern is the structure system that you use for your design should be able to sustain loads. Okay, that's the most. If you ask me, I would say this is the most important thing to be considered in structural design. Okay, it should be able to sustain load um, for that particular space that you're designing. Okay, for example, like um, I mentioned that a building should have some margin of structural capacity beyond what is required of the actual task. For example, this room is designed to cater for, let's say, 100 students, 100 packs. Okay, but if, let's say, especially the structural engineer, when they do the calculation, they specify the load that should be able to be taken by the structure of this space here is ngam-ngam for 100 students, for 100 people. Okay, but as you know, each one of us would have different weight. Okay, so some maybe like just 50 kg, some 70, some 80, okay, some 90. Okay, maybe at average, let's say lah 75. Is it logical? No. Logical, 75. Right. So 75 times 100 people, then that's the load that you cater for. So if, let's say, the designer just consider that kind of load when they design the structure, then if, let's say, one day a group of tourists, visitors, maybe from Fiji Island, okay, they come here, all weighing about like what 100 kg or more, right? But there are still 100 of them, okay, but 100 times 100, just now it's 75 kg times 100. Okay, so if, let's say, that happened, then the structure would collapse because it cannot cater, it cannot sustain the extra load imposed on the structure. Okay, so that's why when you design a structural system, you need to consider, we call it margin of structural capacity. So basically the structure can take more loads beyond what is required, okay, for the actual task. Okay, the margin of safety is defined by safety factor and calculated as follow. Okay, the safety factor, this is just basic maths lah, right? Okay, safety factor SF equals to actual capacity of the structure. Okay, actual capacity meaning that what, for example, like what have been designed for that building, divide by required capacity of the structure. So usually the required capacity is lower than the actual. So when you divide these two numbers, actual capacity divide required capacity, you will get, for example, like if you take this as example, if a structure required to carry 20,000 kilogram and is actually able to carry 35,000 kilogram before collapsing, the safety factor is expressed as SF equals to 35,000 divided by 20,000. Okay, so the bigger number divided by the smaller number equals to 1.75. Okay, so basically we call the safety factor is 1.75. Right? Building structures are generally designed with an average safety factor of about 2. Okay, meaning that if this is 20,000, so the actual load that it can carry is basically 40,000. Okay, basically there's no specific number for this safety factor. Okay, so there's we cannot say that which factor is the best, right? Of course, the higher safety factor, I mean the stronger the building would be, but then it would incur more costs, right? Because you need to use more, let's say, steel bar, okay, for the floor, okay, to construct the floor, right? That would require more cost, right? So I think it's best if we just stick to about 1.75 or 2, okay. Okay, other concerns of structural design apart from safety. Just now, safety includes fire resistance and sustaining loads. Other concerns are feasibility, okay, economy, optimization, and also integration. So when we talk about feasibility, normally the structure that we construct, okay, the building that we construct, the structure must use materials and products which are available and can be handled by the production organization. Okay, so most of the time, especially when we talk about sustainable construction, right? So one of the idea behind sustainable construction is the material is sourced from the site itself, right? So if you are building something in a forest or rural area, so you get the material, the timber from around that site, right? So you don't bring the material from, let's say your site is in Kedah, right? The material you source from Johor, right? So that's not feasible. So that's one thing. So when it comes to structural design, also it should be the same. The structural materials, the structural system that you plan to use for your design should be available locally, right? So I give you an example. For example, like um, actually nowadays you can do anything, right? You can do any kind of construction. The technology are available, right? But the problem is the technology is not available locally. All right. For example, if you know that there is a ice hotel, right? In where is ice hotel? Iceland. No, where is it? Do you know ice hotel? Where is it? Where is ice hotel? Nobody knows. Has anyone been to ice hotel? Okay, so doesn't matter. But actually, the technology is available. Okay, you can create buildings using ice, right? You can create buildings using ice, using a specific technology material. Of course, you use ice lah. The name of his ice hotel, so you use ice lah for the wall and everything, right? But do you think it's feasible to build a ice hotel in Malaysia? No, right? Because of the climate is different, and because of the technology also. And then where do you want to source the ice? Maybe I don't know if you want, there's a huge refrigerator that produce ice blocks. Then you bring, but the problem is to maintain the shape of the ice. Okay, in under our climate here, so it's not feasible to do that, right? And then okay, basically consideration must be given to the complexity of the design, right? And then dollar cost, construction time, acceptability by the authorities, and so on, right? You cannot simply build anything, even though it's the technology is available, right? But you can't simply build anything, right? So you have to consider the cost, especially the cost is the first thing that you need to consider, okay, when building, and also construction time, right? So, for example, if you want to source the material from overseas, I'm not saying that you cannot source any construction or any structural components from overseas. Okay, some projects, especially mega projects, right? Because they want to do something here, so they import the materials from overseas. It's not wrong, but it depends whether the client has the budget or not, and then depends on the construction time. So, how long the construction time given for the project? Okay, because if you don't know, basically in construction, let's say the building is estimated to be completed uh, by this year, end of this year. So for each 1 day late, meaning that let's say the submission, not submission lah, the completion estimated is 31st December 2019, right? So for each 1 day late, if let's say until 1st of January 2020, still you haven't completed. 2nd of January, so haven't completed. Okay, so for each day the late completion, it would incur a cost. Right? So we have to pay the contractor has to pay the client, right? Because if the lateness is due to some issues, okay. So we have to pay, like we call it LAD, liquidated certain damage. Okay, damage for the client, right? So similarly to assignment, right? So for each 1 day late you submit your assignment, okay, so you have to pay with the deduction of marks, right? So make sure you submit your assignment on time. Okay, the third one is economy. First, safety. Second, feasibility. Third is economy. Okay. So just want to highlight again. Basically, these are the keywords that you are going to use in your assignment. Okay, safety, feasibility, economy. So you are looking at these things that I'm talking about just right now, and you have to evaluate the design based on the this keywords. Right. Okay. The third one is economy. Structures are usually less appreciated unless it's constitute a major design feature. Expensive structures do not often add value in the way that expensive finishes or hardware may. Okay, so what I'm trying to say here is basically the structural system that you use for your design normally should be economical. Okay, it shouldn't be too expensive, right? Because especially the clients, they won't appreciate if you tell them that okay, this the structural system itself, because when you construct a building, okay, the QS job, the quantity surveys job, is basically to break down the prices into maybe wall, how much is the cost, okay, structural system, concrete, beam, column, how much is the cost, everything, something like that, right? So the client won't be so happy if you tell them that the structural system costs maybe 50%, right? 60% of the, or maybe more than that, 70% of the total cost. Okay, so basically the money that the client spend, 70% of them just go to the structural system. They won't appreciate that. Okay, they won't like it. So you need to make sure that you use the most economical structural system. For example, like if you are designing a column, right? So you just design the column according to the appropriate size, not too big, not too small, okay, not too long, not too short. Okay, so things like that, right? So they would appreciate more if the money that they spend for the project, the budget that they have for the project, is channel towards something else. For example, like finishes, okay, expensive finishes. Okay, maybe if you say that you cover everything, the column, everything with marbles, okay, gold, then maybe they would appreciate. Okay, but if you just say that you use concrete column, beams, the structure system for the building adds to 70% of the total cost, then they won't be happy with that. But there are some exceptions, not to say exceptions. There are some cases where um, the client, they don't mind of having that. For example, like if you look at this image here, so do you know who designed this building? Do you know the architect that designed this building? Anyone knows? Anyone has been to this building? Yes, Santiago, Santiago Calatrava. Okay, if you know about Santiago Calatrava, basically he's an architect, but at the same time he studied engineering. Okay, after he finished architecture, he studied engineering. So that's why he can come up with very beautiful structural design, because he understands the concept, he understands the principles of the structural system. So normally, Calatrava would design his building. Okay, he would produce architectural design out of structures. Okay, a lot of skeletal design. The structures are very obvious. Okay, so basically, um, from this design, right? So the structural system basically creates the facade. Okay, so you can see here the columns, right? And then here the staircase. Okay, everything is usable basically. So the all the structural component in this design is usable. Okay, so you have staircase, right? But of course, when we talk about economy, I don't think this is economical. Okay, because you spend a lot of money just for the structure. Okay, but especially for government projects, right? big project, mega projects, funded by the government, right? It can be very expensive, okay, and that the government they don't really mind it because they want to have some kind of icon for that place, okay. So another example is like Sydney Opera House, okay. Because can't remember which year it was constructed, but I think it's quite long. Um, because the technology wasn't available during that time. I think in the construction of Sydney Opera House. Okay, so it costs so much more than the initial cost, right? So let's say the initial cost is like maybe seven during that time lah, been few years, not few years lah, many years back, right? So let's say initial cost is 7 million, okay, but the final cost becomes like 40 million, something like that, okay, because of the material, the structure to form the roof, okay. But that's what right now it becomes an icon for Sydney, right? So right now probably the government they don't mind that, even though they have paid so much money for that kind of project. Then number 4 is optimization. Okay, so optimization here meaning that something like balance lah. You need to find balance. You try to balance. You try to juggle everything, all the different aspects in your design. Okay, in the structural design. Okay, but normally sometimes it's very difficult to balance between the need of aesthetic and practicality. Okay, so if you concentrate too much on aesthetic, right, then you would lose practicality. Okay, you concentrate too much on design. Okay, everything just design, design, design without thinking about the practicality of the structure system, and so in the end, it's not balanced. Okay, maybe it looks nice, but then it cannot serve the function, the structural function of the building. And then, for example, safety. Safety. If you concentrate too much on quality, grandeur, and so on, then um, you might degrade safety, feasibility, economy, and so on. Okay, so maybe it's a bit difficult to find it in the assignment. Maybe it's a bit difficult to explain that, right? But yeah, so you should look at the existing design scheme. Okay, in your assignment, look at the existing design scheme and try to optimize between the structural system and practicality and aesthetics in the building. Okay, so often changes that tend to improve one factor would degrade others. Okay, so you try to improve on practicality. Okay, you want to have a very practical um, structural system. Okay, so in the end you would lose on the aesthetic. Okay, so everything becomes very boxy, okay, very rectangular, right? So you would lose on the aesthetic. Okay, next one is integration. Okay, I think the example here is quite straightforward. Okay, it's quite obvious. You can see that it's best if your structural system can integrate, right, between the different function of the building. Okay, for example, as you can see from here, so good structural design requires integration of the structure into the whole physical system of the building. What I show here basically integration between structural system and services, right? So there are many different kind of construction structural system that you can use in your building, right? Some are not integrated, some are integrated. Okay, from the image here you can see that this kind of beams, right? Do you know what's the name of this beam? Anyone knows the name of this beam? This kind of beam? Anyone knows? Anyone? You haven't learned in Beacon 2? Never came across this? You forgot everything already. Totally forgot Beacon 2. You got B, you got A, forgot already. Okay, anyone knows? No, nobody. Okay. This is some kind of what we call as castellated beam. Okay, something like a castellated beam. Castellated beam, I think normally the pattern is hexagon or so I think the shape is hexagon inside here, right? But this is some kind of that kind of beam. okay, or hollow beam lah. So basically it's made of steel, right? Just like I-beam, but normal I-beam is flat, yeah. So here is flat, so you cannot do something like this, right? So if you use normal I-beam or if you use concrete beams, basically you cannot run the all the ducting, okay, for services, pipes, ducting, conduits, and so on through the beam. Okay, you have to put it below the beam. Okay, so if you use the normal kind of structural system, okay, normal beam, normal I beam, in the end, the implication is basically you would increase the floor to floor height of your building. For example, if you are designing a multi-story building, right? So normal building, maybe the floor to floor height, I think this room is what, 3 meter. Okay, so usually it's 3 meter, 3.5. Okay, for bungalows maybe it's 4. So if you use the same height, 3 meter, 3.5 for multi-story building, it won't be feasible, because in the end your building is going to be too tall, but the number of levels that you get is not that many. But if you use this kind of structural system, you can actually reduce the height, right? Because if you use 3 meter, if you use normal beam, let's say concrete beam, let's say the desirable height is what, 2.5 or something like that, 2.5 meter, and then you need to consider all the ducting, okay, piping, and so on. Because this ducting piping, it cannot go through the beam. You cannot simply punch through the concrete beam to put all this thing. Okay, it would weaken the structural system. Okay, so you need to consider that. You need to consider some headroom, okay, for some space for the ducting itself. Then only the height for the beam. Then only the floor on top. So in the end, you would get, let's say, 3.2 meter or something like that. But if you use this kind of beam, you don't have to consider space for the ducting, right? Because all the ducting, piping, everything can go through the beam like this. Okay, so you can reduce the height. So maybe you can just use the floor to floor height 2.5 meter. Okay, for office building, especially multi-story building. Right. So this is on beam. What about this one? What do you think the integration that happens in this image here? What kind of integration that you can you think happening in this structure? Yeah, anyone? Huh? AC, AC, air conditioning duct. Okay, air conducting, right? So basically, this is a column actually, right? So this is the column that supports the roof. I believe everyone knows this building, right? Okay, so basically this is a column supporting the roof, right? But the column itself actually doesn't have to be this big, right? So if, let's say, you cut open the column here, the cladding, everything, you remove the cladding, maybe you can see that the column itself is smaller than this. Okay, it's smaller than this, maybe just that big, right? So maybe just that wide. So what other things, they put air conducting inside here. Okay, so basically they put maybe if I can draw. Okay, so basically the column can be just a straight column like this, right? Then on top you can see the roof. It connects to the roof. Okay, but inside this roof, basically the roof structure. So the roof structure is let's say over there, over here, right? So the first thing is, inside the roof is already there should be some kind of gutter system, okay, to collect the rainwater. So when it rains, okay, when it rains, it collects the water here, and then from here, it channels the water outside the building. Okay, so that's one integration. So there should be some kind of rainwater down pipe inside within that column. Okay, and then at the side here, so there could be some kind of air conditioning system, the ducting of air conditioning system on the side. Then only they cover everything with like cladding or something. Okay, so that's what I mean by integration. Okay, so if possible in your design, you should consider all these things. So um, you integrate the different function or different system of the building together with the structure, right? So for example, like this, I mean, you integrate. You can integrate aircon system. You can integrate downpipe, and so on. Okay, so this is, I think, maybe quite easy. You can identify in the assignment. Okay, so you can see in the existing design whether there's integration or not. Right. So you need to discuss something about integration, and maybe in the because you need to propose something uh, to improve the structural system of the design. So maybe one of the improvement suggestion would be this kind of integration. Okay. Okay, now building construction revision. Okay, so you learn Beacon 2 last semester. I think some of the seniors they learn much longer before. They forgotten already. Okay, when you talk about structure, okay, basically there are two classification, primary classification and types of structure. So these are what you learn in Beacon 2. So geometry, rigidity, okay, solid. Sorry, the primary classification will be in terms of geometry and rigidity, and then the types of structure that you have learned is solid, mass, skeletal or frame, surface, shell, and so on. Okay, so nothing to worry about this thing. Okay, so now I want to ask you, since a lot of you have fallen asleep, okay, so maybe I want to play just like last week. Okay, so you have to call your friend's name. Okay. uh, okay, what is the definition of forces? Definition of forces. Who wants to start first? Hmm, I don't have a dice now, so if I just maybe I can throw to someone. What's the definition of force? Ah, anyone? Devon lah, Devon. since what is force? What do you think force is? Doesn't have to be accurate lah, but based on what you understand. Okay. If Mr. Rizal is here, then he would be very upset because you forgot already what he taught in class. Okay. Energy. Some kind of energy. Uh, you want to call your friend to help? Nikki. Nikki. Yeah. Is it Nikki? Huh? Nicholas. Wow. I was shocked. Nikki, like girl's name, right? Nikki. All right. What is the definition of force? Example lah. I think just give example of force lah. Easier. Sorry. Push something. The what? Okay. All right. I can't really hear you actually. Okay lah. So basically, force is like stresses such as push and pull. Yeah, I think it's correct. Okay. The you mentioned what push? Push. Okay. So basically, push and pull. So one side of the structure pushing. So basically, it pushes down the structure, right? And then in a different situation, basically the load or something is pulling um, the structure, something like that. Okay, what's the standard unit? Standard unit for force. Nikki, call someone. Just make up your mind lah. You don't have to watch that person's face. Just call the name. Huh? Who? What's his name? Remy. Remy. Okay. Remy apa? Standard unit. Newton. Okay. Newton and basically it's Newton lah. So normally we use Newton and kilonewton. Okay. So if it's 1000 Newton, then it's kilonewton lah. Right. So the symbol is N and Kn for kilonewton. Right. Gravitational force. So what is gravitational force? Remy, call someone. Kamalia. No, Kamalia can answer. Gravity. I think it's quite obvious lah. Gravitational force, right? It's obviously. Yeah, it relates to gravity. So one kilogram is how many Newton? 10. Okay, right. So 10 kilonewton. That's 10 Newton. What is external force? Kamalia panggil. External force. Panggil je lah. Bukan last week pun panggil Syed juga. Syed. External force. Quite obvious juga. External tu kan. Ada the word external tu. So it's quite obvious. Okay. Okay lah. External tu meaning outside lah kan. Outside. Okay. So basically it's not to say it's external force is something outside the building, right? So normally when we refer to external, it's like outside the building, outside the space or something. But when it comes to external force, it's more like outside of the material itself. For example, like let's say this is the structure. So even though I'm pointing from here, so it's already considered as external force. Okay. So as opposed to that is internal force. And say it again. Azrael. Azrael. Internal force. Okay. All right. So basically, it's just the opposite. So this is external force. So something from inside the component itself, there's internal force happening inside that. Right. So that's it. Okay. The different types of forces, internal forces, basically. So tension. Have you learned about this last time? Right. Okay. Tension, compression, torsional, shear, bending, or bending. Bending basically is combination of stress between tension and compression. Tension on the outside, compression is on the inside. Okay. Then loads. Okay, so load can be divided into static or dead load and dynamic load, or which is live load, we call it. Okay, and then under dynamic load, we have lateral load. Under dead load, we have point load and uniformly distributed load. Can you give example of dead load? Siapa tadi? Azrael. Panggil siapa? Ivan. Mana Ivan? Give example of live load. Live load ke dead load lo? Example of dead load? Do you think furniture is dead load? Who thinks furniture is dead load? Raise up your hand. It's a bit confusing lah. I mean, okay, not really sure, right? So maybe you raise up your hand halfway. So, okay lah. If halfway also can lah. Raise up your hand halfway if you don't know. Okay. So who says is furniture is a live load? Raise up your hand. Okay. Okay, all halfway. Okay. Dead load? Who said furniture is dead load? Don't know. So I think everyone also not sure. But basically, in this class, right, we consider furniture, okay, especially as loose furniture. So furniture, so there are two types. One is loose furniture, one is fixed furniture. So if loose furniture, it would be most probably a live load, okay, because you can move. Okay, so first maybe today or for this year you want it to be here, next year you want to move to somewhere else. Okay, so that is considered as live load because you can move, right? Even every day, so if you don't like, maybe today you like it here, tomorrow you like it there, so you can move the furniture anytime you want. Okay, that's considered as live load. But if it's a fixed furniture, then that will be considered as dead load, right? Because, for example, like fixed furniture usually like built-in wardrobe, right? Built-in cabinets, that will be considered as dead load lah, because it's fixed. You don't move your wardrobe every day. And then, okay, what else? Mana Ivan? Call someone. Example of just now dead load. Okay, dead load. What else? Example of dead load. Huh? Fikal. Mana fikal? Okay, apa? Example of dead load. Floor slab. Okay, very good. Okay. Floor slab. Okay, lagi? Call someone. Siapa yang ngantuk-ngantuk tu? Panggil sikit. Richie. Mana Richie? What's example of dead load? So if you heard him what he said, so maybe you can relate to that. Wall, okay? So wall, and basically all the structural system is considered as dead load, right? But under the dead load, we have two types. One is uniformly distributed load. Another one is point load. So what do you think would be example of point load? Richie, panggil. Example of point load in a building. Inga. Okay. Inga or Renga? Inga. Okay, Inga. Example of point load. Can you think about any example? Ni. I'm looking at the other person. Okay. Example of point load. Sorry. Or maybe your understanding of a point load. A point load. Column. A column could be a point load if, let's say, it's basically it's a point load if, let's say, in some kind of in certain kind of construction system. Basically, I'm not sure whether previously your lecturers say that all columns should run from roof to the ground. Okay, but actually in certain circumstances, column can stop actually somewhere, especially if you have multi-story building, right? So you want to have a clear span on the ground, for whatever parking or whatever. So you can have a huge beam. We call it a transfer beam, and then basically the column actually sits on the beam. Then only it becomes a point load. Okay. So another one is uniformly distributed load. Example of uniformly distributed load. So just now I think Fika already mentioned slab. Okay, slab is basically one example of uniformly distributed load. Okay. So live load. Just now I already mentioned, if it's a loose furniture, then it's considered as live load. So what is not other example of live load? Inga, call someone. Kish. Kishon. Kish. Balkish. Sorry. People. Okay, very good. Right. So people is one example of live load. Okay. Okay, people, wind, okay, snow, wave, and so on. Okay, I think you're running out of time. Okay, structural requirements. I still have a long way to go. Okay, so structure requirement, basically when you design a structural system, you need to make sure that your structure is capable of achieving a state of equilibrium. You'll see what it means afterwards. State of equilibrium. Number two, it should be stable. Okay, the structure should be stable. Number three, it have adequate strength. Okay, it should be strong. So basically, it should be strong. and should have adequate rigidity. It should be rigid enough, right? So equilibrium is the state of rest under the action of applied load. Okay, all applied loads are balanced exactly by the reaction forces generated at its foundation. So basically, the meaning of equilibrium. So whatever you have, amount of force you have imposing on the building on top. Okay, so the same amount would be needed, okay, to balance the building from below. Right? But don't be confused between equilibrium and stability. Okay, because if you look at this image here, this composition or this this is not really a structure. Okay, this arrangement is in the state of equilibrium, but it's not stable. Why? Because once you add maybe another pebbles, right, on top, then it would collapse. Okay, because it's not stable. Right. So don't get confused between stability and equilibrium. It is stable in the sense that the amount of forces are balanced. Okay, so in that sense, it's stable in terms of that sense. So the amount of forces are balanced between the top part. Okay, let's say this is like how many Newton, and then the forces from below required to balance the object is in the same amount. Okay, so that's what equilibrium means. Okay, so the same applies to this Pisa Tower here. So I think most probably when the person designed the building, right, it should be straight, right? So during that time, the first time that the building was constructed, when it was straight, okay, basically it was in the state of equilibrium, right? Because the forces are balanced. Okay, the amount of load generated from the building is balanced with the amount of forces required to support from the ground. So it is on that state. But over the years, it loses the equilibrium bit by bit. So in the end, right now, the new equilibrium for this structure is like that. Okay, so because it's already, I hope it's already stopped reclining. Okay, so I'm not sure whether it will collapse in the future or not. Okay, but this is the new equilibrium for Pisa Tower. Okay, so now it is at the state of rest. Okay, the forces on the ground, okay, and the forces on top is actually at the same amount. Okay, so that's why it becomes like that. Okay, but it can change. I mean, the equilibrium can change now over the years. So things like that. Okay, stability. Okay, as I mentioned just now, don't get confused between equilibrium and stability, right? Because as I showed the image there, the structure, the pebbles especially, the arrangement are not stable, but it's in equilibrium. Okay, in this case, basically, stability is the property which preserve the geometry of a structure. So as long as the structure, when you put some force, okay, like this, the structure is like that. Okay, just a column and beam. But if let's say when you under normal circumstances, it's like that. But if you put some additional forces, then it would lose its geometry. Then it is not stable. Okay, so we say that the structure is stable if when you put additional load on top or from the side, whatever, it still maintains its geometry, okay, its shape. So it doesn't change, it doesn't collapse. It still maintained. Then we can say that the structure is stable. Okay. So it is possible for a structure to fall due to its being geometrically unstable, even if it has sufficient strength and rigidity. Okay. So it relates to stability, relates to strength. Okay. Even though your not to say relates, how to say it? Even though your structure, the material that you use for the structure is strong, for example, you use concrete, you use steel structure, okay, but because the arrangement of the geometry is not stable, so if you put additional load, then it will still collapse. Then you cannot. It is still not stable, even though it's strong, even though the material is strong, but it is not stable. Okay. So the structure can be strong, but not necessarily stable. Okay, strength, obviously it depends upon the material properties. Okay, for example, like of course steel is stronger. When we talk about strength, meaning that it is strong. The steel is much stronger than timber. Okay, concrete is much stronger than timber. So things like that. Okay, you're talking about the property of the material itself. Okay, the strength of material depends on its capacity to withstand axial stress, shear stress, bending, and torsion. That will be we will cover in the next lecture. Okay, rigidity is a property that makes a structure does not bend or flex under an applied force. It is something like stability just now, but stability refers to the overall structure of the building. Okay, then we say it's stable, but rigidity is more towards the component itself, the arrangement of material within the components. Okay, so if we arrange the material, for example, trusses, you use trusses, truss structural system. If you use truss system, there are certain ways of arranging the what they call it, the component, right? Certain arrangement will have more rigidity compared to the other components. So it depends. I mean, it refers to the material of the structural system. Okay, some structures are formed by collections of objects that are rigid bodies with pairs of objects connected by flexible hinges. Okay, structural failures. Structure fails due to the following. First is stability failures, relates to overall structural system. Okay, if your structure is not stable, right, then it would fail. So normally the structure, especially like building structure, this one is a infrastructure, infra like roads and so on. When we design that kind of structure, basically at first, originally it is stable, but what makes it lose, what makes it fail, it loses stability. I think probably in this case it might be because of earthquake, right? Because the energy, the force of the earthquake is too much that the structure cannot sustain. Then that's why it fails by stability. Okay, it's not that because the engineer miscalculated the column size or and whatnot. Okay, normally it's because of the earthquake and so on. Okay, and then strength failures relates to the strength of the individual structural members. In this case, timber. Okay, so as you know, like certain materials over the years, if it's too old, like just like people if it becomes old also we lose our strength, right? So we cannot walk, we have to use what, tongkat and so on. Okay, so similarly goes similar to structural materials. Okay, over the years, especially for timber, even for steel, right? So it would corrode and so on. So it would lose its strength. Okay. Basically, actually, there's a video lah, but then because we only have 10 minutes, so I need to rush a bit. Okay. You can watch this video later. I put it in Times. I put it in Times, so you can see. Basically, there are 6 different projects. 6 different cases. I mean, relates to construction failures. A different kind of failures, basically. Some fail due to strength, stability. Okay. I put it in Times, so you can watch the video. All right, structural members, basically generally there are 2 types of structural members: horizontal members like floor, roof, beams and girders. The second one is vertical members like columns and load bearing walls. And then load path, basically how the load travels inside the building. The path that load travels through a structural system, basically is something like that. Okay, you can see the arrows. Okay, first from the roof. Okay, let's say there's a mechanical system, services system included inside the roof. Then the weight of that component should be considered as well. So the load from the roof is transferred to the beam. Okay, and then from the beam, from the middle, it distribute evenly. One goes to this side, to this column, and this side goes to this column. And then as it goes down, it adds the load from here, from this slab. Okay, the load from this slab, whether it's live load, I mean it carries live, obviously it is carrying live load and dead load. The load will be transferred to this column, so it would add to the loads which is already from the roof. And then here it goes to this column, adding to the load on the column. And then plus this level, plus this level, then it would be transferred to the ground. Okay, so normally in construction, usually would have the same size of column from ground to the roof, but actually looking at this, because the amount of load that the column supports are actually different between levels, actually it's possible to do this, meaning that you can have a bigger column at the lower level and a smaller column on the upper level. Okay, so because the amount of load carried by a column is different. Okay, but of course, like in construction, you when you create columns and when you want to construct a column, you use formwork. So maybe it's more economical if you use column in the same size because you just use the same formwork. Okay, and then every load applied to the building will travel through the structure system until it is transformed. It is transferred to the supporting soil. Okay, I've already mentioned. For a truss system, okay, especially for the roof, this is how the load is transferred. Right, so from the top here, it is transferred to the all the components of the roof truss and then to the column. Okay, so this is the one that I mentioned. In some cases, but not all the cases, it is more economical if you have columns from ground to the roof. But in some cases, if you need to do this kind of construction, it is actually possible. You have a column here on the ground, right? On the upper levels, you have 4 columns, but then on the ground floor, you have only 2 columns. So all the columns from the upper level is transferred to this transfer beam here. Okay, but whether it is economical to have that kind of structural system, that's a different story. But it's actually possible. So this is what I mentioned earlier. When the column sits on the beam like this, then only it becomes a point load. One example of point load is like this. Okay, the column sitting on this beam. So basically, you can see that there's a point load here. So basically, in this beam, there are 1, 2, 3, 4 point loads because it's not the load is not transferred directly to the ground. Okay. Okay. This is from different angle. Basically, you can see how the load is transferred from the column. Okay, from the slab. So basically, if let's say you have so many beams here, so from this beam, it is transferred to this column. From this beam transferred to this column. Okay, and then from each beams it goes to the nearest column, right? Then it is transferred to the ground. Okay, I think I don't have to this one is under Mr. Rizal. Okay, I think that's all for today. All right, so just take sorry. So please check your tutorial group. So you just go to your appropriate tutorial group. Okay. So I'll see you in studio D311 and D312. Okay. Thank you. Kevin Shim. Kevin, can he join you? No, bro. You have only 4, right? You have 5, right? Including Rajan, right? So maybe you take another one. Is it okay? Yeah, yeah. You take another one.
Hi, sir. Hi. Okay, now? Yeah. Okay. All good, all good. Then concentrate in studies. Which means that you can score again A every subject. Inshallah, inshallah. The project is the same, quite same lah, similar. Project 1, project 2, but project 2, today we put in a group lah, one plan, but you need to calculate lah. But most likely the same lah. It's the same in a group, yeah. So if your grades are good, right, B plus and above, why not just maintain the grade? Just concentrate on your final exam. Now you are working, right? But you need to discuss the thing. Whether you allow it or not. Are you in my group? Oh, yeah.
Where do
You
you
meet in studio? Studio. Are you studio? Where is your studio?